All right, welcome back to episode 2 of the front engine or the front tine tiller. So, where we finished off the last video, we had just completely disassembled this entire engine. I've gotten a lot of things cleaned up, and I'll walk you through the process on kind of how I did that. So, the first thing I wanted to address was the scarring on the inside of the cylinder wall. So, how I fixed that was I took a hone. And these ends right here are an abrasive stone, right? So you take this and you chuck it into the end of your drill, spring loaded, and you just put that in there just like that, and then turn your drill on and it spins in there just like this, and you move it up and down, put some lubrication on there, move it up and down, and it just kind of shaves off the outside layer there. So some things to be careful of is you don't want to hold it in one spot while it's spinning, because then it will oblong this cylinder wall. You'll get it a little bit bigger in one spot, and that would cause issues for you. So when you hear people talk about putting, boring out the cylinder walls and putting bigger pistons and all that stuff in their cars for more performance, that's essentially what that is you're making this bigger so that you can put a bigger piston in it. By putting a bigger piston in it, you make a bigger combustion chamber, which gives you more volume, more power. Okay, so if you mess up this cylinder wall, you're going to have to end up buying a bigger piston and bigger rings, because the original piston and rings will not fit tight enough in here to hold compression. So you got to be careful with that. The second thing I did was I cleaned up these valves. If you remember, these valves were all pretty crusty and burnt looking. So how I did that was I took this end of the valve and I chucked it into my drill. Now, be careful with that, because the little jaws on the inside of your drill that hold your bits and all of that stuff are hardened steel. This is not hardened steel. So if you're not careful, you can mar up these valves real easy. And I don't know that there's any replacing that. If you get them marred up bad enough, you just have to replace the entire valve. But what I did was I chucked it into my drill, and I took a piece of just Scotch Brite pad, and I sprayed a little bit of WD-40 on it, and I spun it around, and I just held that Scotch Brite pad until it took every bit of that carbon buildup and burn off of it. So I did that with both the intake and the exhaust valve. Now, once I got the valves cleaned up, then I focused on the valve seats. And how I got these cleaned up was I took a little wire wheel that goes into my drill, and got in there and cleaned up as much of that as I could. Now, it did leave a little bit of residue behind, and all I did was just took a little screwdriver and just lightly went through here and got all of that stuff out as much as I could. Again, be careful with that, because you don't want to mar or gall up that valve face or that valve seat. Once I got all of that cleaned up, I relapped the valves. So what that means is you take some valve grinding compound, and it's a real thick kind of Play-Doh-y type consistency, but it has like grit in it. So you take that and you put it on the face of that valve, and there's a special tool called a valve lapping tool, right? So you put that on there, on that valve, and then you stick that valve in there, and these little suction cups suction down on it, and you just work that back and forth, just like so, until you get that valve seat lapped back in. And what you're looking for, I don't know how well you can see it, but what you're looking for is, you see how it's all kind of shiny, except for right out here, there's that kind of dull matte finish line all the way around the valve. And that's what you're looking for, because you know that valve now completely seals around that seat. So once I got the valves relapped back in, then I took a sheet of 300 grit sandpaper and I taped it down to my bench top, and I took this block and I turned it upside down and I just ran it around in a circular motion on that sandpaper until I got this the top of this cylinder head kind of, because you'll get high spots in here, especially around the heated areas, because it heats and shrinks and heats and shrinks and heats and shrinks. You'll get little ridges and valleys kind of in here. So I wanted to smooth all of that up. That way, when I go to put the new head gasket and the new head back on, it is a completely flat surface for this to mount to. So because I did that to the top of the cylinder, I did it to the top of the head, or the bottom side of the head as well, where that mating surface comes together. Also, there was all of that carbon buildup on the top side of this head, so I did the exact same thing with the wire wheel and little screwdriver and got all of that carbon buildup out. Okay, so once I had all of that done, there was quite a bit of kind of sludgy material down in here, kind of in these little corners. You can still see a little bit of it down in there, but there's a lot of that sludgy material all across the bottom of that crankcase. So how I cleaned that up was just warm water in a bucket with some like Dawn dish soap. Put it in there and just kind of scrubbed on it with a brass wire brush and then some of those Scotch-Brite pads, and got as much of that cleaned up as I could. That way when we start the reassembly process, everything is as clean as it can be. Before I forget, going back to the valves, before I lap the valves in, I wanted to clean up and make sure that valve seat didn't have any kind of, ridges or catch areas or anything like that. So what I did was I took a little piece of 1,000 grit sandpaper, just, about that big, and I cut this side out here and then little wings in it so that I could take the valve itself and put it over top of that, just like so. And then I could wrap this all the way around to where it gives you a little handle, and then stuff that valve back in there and just work it back and forth to make sure that this was all smoothed out real good. You do that before you lap the valves in, so that way we make sure that that mating surface is as good as it can be. Because we talk about, when we pulled it apart, you saw how carboned up all of that was, and if that carbon is preventing that valve from closing all of the way, that's where compression loss is going to occur. So now that we have gotten this to this point, I think we're ready to start putting things back together. So in the other video, we talked about the not getting any spark, and so this was the coil that was on it, and this is an old, what they call a breaker point style ignition system. So what happens is this gets mounted just like that. You have your points. This would get mounted here, and as the engine spins, there's a spot on that crankshaft, almost like a camshaft, and it pushes this plunger up. Well, when it pushes that plunger up, it breaks contact between these 2 points. So when it breaks that contact, it's obviously not getting an electric signal, but when it comes back down and touches it, then that's what sends signal up to send spark to the spark plug. Now, this is an old school method of ignition, and when these things work, they work fine. The problem is they're very prone to not working. And in this case, if this were to stop working and I have to go back in and fix it, because the most common thing is you'll get like just some corrosion on these point tips, right? So you just have to go through and sand them. Well, the problem is the way this engine is designed is you have to pull the front cover off of it, then you have to pull the flywheel off of it, and then you have to pull this points cover off of it just to get to that to service it. So a much more efficient way is the electronic ignition, and it's kind of what Briggs and Stratton went to in the early 80s. So we're going to convert this over to an electronic ignition system, and how we do that is the engine that's on the engine that's on the tiller right now had an electronic ignition system, just like this. So instead of having all of these, that's your condenser there. So instead of having the condenser and the points and all of that stuff, this little module right in here is what takes the place of all of that. So it is as simple as just putting this coil on this motor, and now it's an electronic ignition. So if there's a problem with the ignition, it's much easier to address the issue and fix it. But if you were going to buy a kit to convert this over, you would have to remove this. So this arm right here is attached right there by that little bolt, and it's spring loaded. So that's what keeps it from pushing back. Well, this plunger, if I move this out of the way, that plunger just kind of free floats in there. That spring is what keeps that plunger pushed back in. So as that crankshaft spins around, that's what moves that arm. Well, they make a kit that comes where you can pull all of this off, and it's just a plug that goes in there. Well, I don't have that because we're trying to do this on a budget. So I'm going to leave this in there so that no oil leaks out of here and no dirt gets down in there and none of that. I'm just going to leave it and put the points cover back over it so that all of that is kind of as secure as it can be. Now, when I went to clean all of this up, I pulled the oil seals out of this side of the block and on this side of that front cover. So the gasket kit that I bought came with new seals. So we'll get those drove back in, and then we'll start the reassembly process. Now, when you go to start reassembling this engine, you're going to want to get some kind of assembly lube. This is what I use, but assembly lube is kind of a sticky, thick oil, basically, is what it is, because you want to have these moving parts lubricated when you put it all back together. That way, when you try to start it the first time, it's not trying to start it with dry components on the inside. It's specifically in that rotational area of the engine. So you will see me here in a minute. I'm going to put some of that on the tappets before I stick them in. I will put some down into this journal for the camshaft, and I will put that around the piston. When I go to set it back in to here, I'll put it on the crank journal where the connecting rod goes down and connects into it. I'll put a lot of that stuff in here. So you can buy all different kinds of assembly lube, and there's people that actually recommend using just regular grease, and I don't like that because I don't want grease just floating around in the engine. But essentially all grease is oil that's been suspended into a real viscous substrate. So it would work, although I don't necessarily like it. So just get some assembly lube. So also, I don't know where you guys are located, but I'll tell you that in this part because we're in Northeast Oklahoma, we haven't found a machine shop that will do machine work on small engines at all. I don't understand why. I don't have an answer for you why they won't do it, but that's why we have to hone out the cylinder ourselves to clean out those ridges. That's why we have to use sandpaper taped to the bench top so that we can level this surface out. Those are the reasons that we do these things. And also, because we're trying to do this on a budget, it wouldn't be real cost effective for you to pay somebody to do this. because although it takes me a little bit longer to do this because I'm filming for YouTube, but I've already got a couple hours into this, and I haven't even started reassembling it yet. So you talk about having to pay somebody an hourly rate, shop labor, to put this stuff back together, pull it apart, clean it up, fix it, put it all back together. It wouldn't be cost effective for you to pay somebody to do it, which is why I'm showing you how to do it, so that you guys can actually do this on your own, save you a little bit of money, and get you a piece of equipment that's going to last you a long time, that's good and dependable. So let me get reset up here, and I'll bring you guys back in when we start the process. Okay, so I got the crankshaft set back in there. So now what we need to do is get the piston drop back in there. So how we're going to do that is you got to use a piston ring compressor, because you have to compress these rings back in here to get it to fit down into that cylinder wall. Now, I've put some of that assembly lube on here, and when I tell you that stuff is sticky, it is sticky. So, we'll get this set just like so. Get this ring compressor put down over top. Alright. So then we'll tighten this down. Get this tightened down to where it will compress those rings. And we'll get that piston drop down in there. Okay. Get this set back in there. Just like so. Tighten it down just a skosh more. And then just take plastic or wooden end of, or handle of a hammer, and just kind of tap this around. Make sure it's sitting down good. And just tap that piston down in there. There you go. So, I didn't tap it down much further than that because I have to make sure that as it comes down, it connects on that crank journal. Because it has to go around this right here. So I'm going to put a little bit of that assembly lube around this. See, I told you that stuff is sticky. Just kind of work that around real good. Now, if we were putting a new piston rod, or we were putting a new crankshaft or something like that in there, we would have to check the gap between this journal and the connecting rod itself. And you do that with what's called a plasti gauge. But since we're not doing that, we'll be okay just to reinstall. Make sure that's still good. Alright, so now rotate this around. Take that around. go. Now, trying to get that piston down to the bottom point so that I can take a connecting rod and install it. So this will go up onto the bottom of that connecting rod, and then this will screw onto the bottom of. These are the screws hold that connecting rod up there. This piece right here is your oil dipper. So as that piston moves around, these little deals splash oil all inside the inside of that engine. So let me see if we can get these at least started in here. Now, this oil dipper will only go on one way. You have to put it on in there this way, because if you put it in there backwards, you won't get to the nuts to tighten them, or the bolts to tighten it up. So it can only go in there one way. Okay. So, yep, there we go. I'm almost positive you guys can't see at all what I'm doing in here, but the problem is there's not really a lot of room to work in here. Alright, I got that one started. Alright, let's get this other one started. There we go. Alright. I'm pretty sure those are 7/16, and I am correct. I'm just gonna get those snugged down because there is a torque value for both of those. So we want to make sure we get that torque to the right spec here. I'm just getting it snugged down. They are a bit long-winded. Bear with me, guys. Alright, those are snug down now. As you can see, piston seems to be moving free. I like it. All right. So now get that out of the way. All right. Let me find. I've got my torque settings written down somewhere. Let me find my torque settings, and I'll get you guys back when we continue on. All right. So, a twisted turn of events. My torque wrench is only 3/4 inch drive, and I don't have a 7/16 socket in 3/4 inch drive, nor do I have a reducer. And even if I did, I don't know that there'd be enough room to get them in here. Now, I will tell you that it only calls for 9 foot-pounds of torque, which is not a lot. So if you are like me and you're in the position where you don't have one of those, you're just going to have to do the best you can. And my recommendation is just get them to where you feel comfortable. Okay. All right. So now let's get these tappets put back in. Get them cleaned up real quick, and I'll put some assembly lube on them. Now, here in a minute, when I go to put oil in this thing, you guys are going to see me put some Shell Rotella T oil in it. And if you've watched any of my other videos, you've heard me preach about not putting automotive oil into these small engines. Well, that is true. The reason for that is because regular automotive oil doesn't have the zinc content required for these small moving parts. And because the engine itself is air-cooled and not water-cooled, it operates at a temperature of about 350 degrees. Normal automotive oils are not designed to operate under those temperatures. Now, here's where Rotella is different. Rotella is a heavy-duty diesel oil. It has a very, very high zinc content to it. The reason that I'm using it in the very beginning, as a break-in, if you will, is because there's always going to be some sludge or particulate or something like that in the engine throughout this process. Rotella is a high detergent oil. And what that means is it has a cleaner in there that will clean all that stuff out through a couple of heat cycles. So what you'll see me do is I'll put the Rotella in here to begin with, and then after probably half a dozen or so heat cycles where the engine gets up to operating temperature and then cools down and then gets back up to operating temperature again, I will drain that oil out, and I will run a Briggs and Stratton oil in this throughout the duration of its life from that point on. So let's get these tappets stuck back in here. Ugh. Of course, this governor arm is right in my way. There we go. Now, this assembly lube is sticky enough that it should hold that up there. Seems to be working swimmingly. Perfect. All right. Now, we go to put the camshaft back in, and we have to make sure this is in time. So, what I mean by that is, you look on this crank gear right here. I don't know how well you can see it, but right in front of my finger, there's a line in that gear. That is the timing mark. because there is a spot on the camshaft right here, that little divot, that is the timing mark. So you have to rotate this around to where both of those marks meet up. Once you do that, then the engine itself is in time. So after we do that, then we'll get the side cover put back on it. Then we can start checking valve clearance and all of those other things, and then start getting the valves put back in. But what I'm going to do is put this assembly lube on the lobes of this camshaft, just like so. Good Lord, this stuff is stringy. Get that stuff on there real good. Like, you start messing with this assembly loop, if you don't get it everywhere, you're not doing it right. God, this stuff gets everywhere. It's as bad as never sees. Alright, spin this around. There we go. Alright, so you can see those two timing marks are lined up. So now that means this engine is in time. So we're ready to put this side cover back on now. So the gasket kit that I bought with this came with several different size gaskets. The reason for that is because you have to have a little bit of end play, what they call end play, on this crankshaft. So what that means is that that crankshaft has to be able to move a little bit in there. So they give you different thicknesses of gasket for this side cover to make sure that you can get the right amount of end play in there. So I am going to start with the thinnest of these gaskets, kind of work my way up from there. Oh, for Pete's sake. Come on, dadgummit. That looks to be the thinner. It would help if I put it on the right direction. Okay. Now, you didn't see me put any assembly lube on this end of the crankshaft or on that end of the camshaft. You will. I have to make sure that I've got this correct amount of in play before I go off and do any of that. There we go. 1962. Now I'm not going to torque these down either. I'm just going to get them on there. Like, there is a torque value, and I will torque them down once we're done. I just need to get a couple of these snug down in here so that I can make sure we have the right amount of end gap. There you go. That's perfect. All right. So I'll pull these back out, slap some assembly lube on those moving parts. We'll get the side cover put all the way on, and then we'll start checking valve clearance. Oh, come on. There it is. There we go. Man, this stuff is sticky. But the purpose behind this stuff is so that you have lubrication to all of these parts that will stay there. It won't run no matter how long you leave it sit. It's not going to run and leave these parts dry before you get a chance to start it. It is. All right. Moving just like it should. All right, so now we need to find, so that exhaust valve or the intake valve open, intake valve closed, exhaust valve open. That should be top dead center right there. So that is where we're going to check our valve clearance at. So what that means is when we take this valve, is this an intake? Take that intake valve and stick it down in there. We need to look and see how much gap is in between that lifter right there and the tip of this valve. So, according to the service manual, the intake valve should be anywhere from 5 to 7 thousandths. Now, I always err on the side of caution and go to the bigger size. The reason for that is because as this starts wearing down, that tolerance will get a little lighter. So if you go with the bigger gap, it gives you a little bit more longevity out of this. Let me get both of these valves taken care of and I'll bring you guys back in. Okay, so if you guys can tell, due to the power of movie magic, this is not the same night as the last time we were working on all of this. So I basically what happened is I fat fingered the phone and it didn't hit the record button, and I had no idea that it wasn't recording until after I put these valves in. Now, I'm ashamed to admit how long it took me to get these valves in because I don't have the right valve spring compressor. Now, you put the valves in, there's a keeper plate on the bottom that hooks into the notch on the end of the valve, and that's what holds it in place. Because it took me so long to get them in, I'm not going to take them back apart to show you how to do it on camera. Just know that if you have the right equipment, it makes everything much, much easier. And so this type of valve spring compressor works great for engines that have like an overhead valve head. So not so much with these. The kind you need for these valves or these valve springs are, it's kind of like a pincher shape, if you will, where both ends of it go in here and they compress the valve spring, and then you can pull the pin off the bottom and then pull the valve out and then put them back in the same way. That is not how I had to do it, but I got it in there, and that's what's important. So we're going to continue on. We'll get this valve cover put on this side. We'll get the head put back on, start reassembling this whole thing so that we can do another compression test on it to see how much better the compression is now after we've refreshed this engine, okay? So, exhaust stroke, intake. Alright, so now we are back to top dead center on the compression stroke. So let's get this valve cover back on. Let's get the flywheel back on and start assembling these parts. Okay. All right, so the valve cover has a gasket. Pull these out. The valve cover has a gasket. I really need to clean that up. So the gasket has these two little notches right here on the top side. I don't know if you can see that or not. Right there and right there. So those little notches correspond with these spots right there. So that's how that gasket goes back on. And those holes look like they may be offset just a little bit to make it to where you can only put it on one way. But so we'll get this put back on. Have to be like super torqued down, just enough to make sure that gasket seals and it's not going to leak any oil on us. All right. Okay, so the head gasket will only go on one way, because if you look, the exhaust valve is actually smaller than the intake valve is, and while these holes here are symmetrical, these ones are not. So if you tried to put the head gasket on backwards, your holes wouldn't line up. Okay, so get your holes there to line up, right? And we take this head, So then, put this back on with this plate, just like so. There we go. Okay, now all right, now I am only using my impact drill just to get these seated down on there. There is a torque value and a specific sequence that these have to be torqued to. Okay, so now that I've got those down on there, let me get my torque wrench set up, and I'll tell you what sequence these have to be torqued down to and to what torque setting they're supposed to be at, okay? Okay, so the torque setting for these, each one of these head bolts is 13 foot-pounds. When you look it up on Briggs and Stratton's website, it gives it to you in inch-pounds. I don't have an inch-pound torque wrench. I have a foot-pound torque wrench. So, converted inch-pounds to foot-pounds, there you go. So the torque sequence is, so if this is the side that your valves are on, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. I'm going to torque each one of them down to 13 foot-pounds. Trying to keep this from spinning on me. Okay. There we go. Alright, so we got the head torqued down now. Always, 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 when you're done with your torque wrench, loosen the tension up on it. Always, always. Alright, so we got the head put back on now. We need to get the flywheel back on and the side cover back on. And then I'm going to go ahead and, well, just get the flywheel cover back on, and or the flywheel back on, and then the cover put back on. Get the coil put back on, and then we'll run another compression test on this. See how we're doing here, okay? So this flywheel is keyed, has a Woodruff key in it, okay? That Woodruff key looks just like this. So there's a groove in that flywheel right here, and it matches the side of the crankshaft right there to make sure that when this magnet comes around and interacts with the coil, it sends fire to the spark plug at the same time. It's all a timing issue, okay? So slide this back on. We'll slide this Woodruff key back in here. If I don't drop it. Okay. Woodruff key wasn't so small. There we go. There it goes. All right, so now that that Woodruff key is in there, get the little spacer. Now it's time to put this clutch back on. Now, that's actually pretty good. You can take these and unscrew these little screws and pry this cap here off and get down in there to where those ball bearings are if it's real sticky, but this one is actually not that sticky. I thought it was during the initial teardown process, but it's actually not bad at all. So we'll get this put back on. Okay. I'm going to try something. I don't know if this is going to work or not. I bet it does. Because this has to be torqued down to 55 foot-pounds. Okay? So, if you don't have that puller for this, you can take a 7/8 socket, bind up this flywheel itself, and get that torque set just right. So give me just a second. I don't think it was that one that I used. It was this one. Okay. Alright, so we're going to get that jammed on there just like this. Get our torque wrench set to 55 foot-pound. All right, 55 foot-pound. That's what I'm afraid of. There we go. Reduce our torque wrench back down. All right. Good. I like it. Perfect. All right, so now we need to get the coil set. All right, so when I took this coil off of the donor engine, I went through and used a little wire wheel on my small Dremel, cleaned up both of these areas right here, cleaned up both areas on the back side around there, cleaned up this area right here where it mounts to, and I cleaned up these surfaces here along with the surface on the flywheel itself. Now, if you'll look, these holes are not circular, they're rectangular, okay? And that's so you can get a proper air gap in between this and the magnet on the flywheel. Okay, so what we're going to do is get this started on here. You move that magnet out of the way and it won't be fighting you. So get the right size socket. That's it. Pull this flywheel as far away, or pull this coil as far away from the flywheel as you can, and just snug it down. It doesn't have to be tight. You'll see why here in just a minute. Okay, so we've got that snugged up. Now we'll rotate this around to where that magnet is right under that coil, just like that. And we're going to find a business card, because a business card is the exact thickness that you need it to be for your air gap. So what we're going to do is take that business card and slide it in between the coil and the flywheel. Then we're going to loosen these both back up, and you should see it magnet back down, just like that. Just like that, okay? So then you take, now you tighten these back down. Get them good and snug now. Not too much, because you don't want it to break that stud off on the block. If you break that stud off on the block, you're in big trouble then. Okay. And you just spin this. Get that card out of there. Beautiful. Spin it around a few times, make sure you're not catching. I think we're golden. All right. So now it's time to get this front cover put back on. Now, if you remember when I was testing this initially, I had some issues with the recoil not wanting to go all the way back in to the starter itself. So there's an easy way to fix that, and how you do that is, so if you look at it just underneath the pull rope itself, you see this little space right here. Shoot some WD-40 down into that, and then shoot some WD-40 down in the center, and you can put some right along the back side of this if you want as well, from where these clips right on it. But shoot a little bit back in there, shoot a little bit right in here, and that should solve an awful lot of your problems. I did that just before I kicked the camera back on this time, and as you can see, no problems at all whatsoever. All right, so let's get this front cover put back on. So how we're going to do that, tilt this engine back. Now this little notch right here on that heat shield is for the spark plug wire to come up through. So we need to make sure that that comes up through there. All right, just like that. Perfect. Make sure our kill wire comes out the side. Alright, so now we've got the 2 bolts that go on the bottom and the one that goes in the top. Let them cinch down. Okay, so I got the front cover back on. I've got it filled up with oil like I told you guys. Using some Rotella 10W30. I've already explained why I'm going to use it. I'm only going to use it for a couple of heat cycles, and then I will drain that out and I will run Briggs and Stratton brand oil in this. So we've got everything. Let's check compression now and see how much we've improved over our base, and see how well we've done here. Alright. Get that tightened in. Oh, come on. Come on now. There we go. All right. Get this spun around here. All right. Moment of truth. All right, we're sitting at about 60 psi, which gave us a little bit more compression than what we had, but overall I believe the engine is significantly healthier than it was based on what we've done to it. So I think that's where we're going to stop this video. The next video in this series is going to be on getting the tank cleaned out, getting the carb cleaned out, getting it mounted back on the engine, and then maybe 1 or 2 more videos in the series, getting it mounted to the tiller and getting it running, and then maybe we'll start churning up some ground. So thank you guys for watching this. I know it's been a while since the last video came out, but I mean, like I said, this is not my normal 9-to-5 job, so sometimes life gets in the way. But if you have any questions, absolutely give us a call at the shop. The number is 918-443-9393. You can visit us on the internet at mustangmowersulaga.com. You can shoot us an email at mustangmowers401@gmail.com. As always, guys, thanks for watching. If you enjoyed the content, please like, share, and subscribe. Appreciate your time.